Hello. Today we are looking at the binomial distribution. In our previous discussion, we looked at the Poisson and the exponential distribution. So we are going to look at how to work for the expectation of the binomial distribution and the variance of binomial distribution. If you recall from our previous discussion, we said in the case of the binomial distribution, you perform an experiment for period of time or for a number of time. So that is the n. And with that experiment, you have only two possible outcomes, right? That is either 1 or 0. It's okay. So when you have something like that, that is what we term as binomial distribution. So in that case, how do you calculate your expectation and the variance? So expectation of that binomial distribution is always equals to NP, and the variance of the binomial distribution is same as NP into brackets 1 minus P. Is okay. So first of all, let's start with the proof for expectation. Proof for expectation. Yeah. So it said expectation is the same as summation of I, or in this case x, equals to 0 up to n x multiplied by p of x. Because binomial falls under the discrete case. So this is what we're supposed to use. It falls under the discrete, right? So then I can say that then expectation of x is the same as summation of x equals to 0 up to n. Then multiply by x. Then what's the expression for the probability of x? Expression for probability of x is what? N combination x p to the power x, right, into brackets 1 minus p n minus x. This is the expression for the probability binomial distribution, right? Great. So once we have this, we can also say that this is also the same as summation of x equals to 0 up to n. Let's try and expand this one. So when I expand this one, I'm going to have x multiplied by the expression is n factorial all over x factorial into brackets n minus x factorial. Then probability of x 1 minus probability of n minus x. This is what we have. So we can just expand to take out this x. So when I do my expansion, I'm going to have it as is equals to summation of x equals to 0 up to infinity. This x already is there. And I have my n factorial all over the x can become x into bracket x minus 1 factorial multiplied by n minus s factorial is okay, and s factorial. And then in that case, this is supposed to be, instead of writing x minus 1, I can write p brackets x minus 1. Then I'll bring multiply by p, right? Because this expression was only p exponent x. But once I'm adding minus 1, I just have to multiply by p again, so that when I add exponents, I will still have my this one back, a p exponent x back. Then 1 minus p n minus x, right? So this cancels this, right? Now because this one is starting from, now this one cancel this, is okay. Now because I'm starting is x minus 1, then this part must start from 1, because if it starts from 0, it could be x 0 minus 1 is negative 1, and negative 1 factorial does not exist. So I'm going to write it as equals to summation of x equals to 1 up to infinity n factorial all over x minus 1 factorial. So let me take the p here also, or this p, let me take it out. I have p here. Great. S minus 1 factorial n minus x factorial multiplied by p exponent x minus 1 minus p, then exponent n minus x is okay. So let's try and simplify the expression that we have here. So I can say let y equals to x minus 1, represent this one here. And then let m also equals to n minus 1. If that is the case, then I can say s is equals to y plus 1, right? S equals y plus 1 from here. And then y is m is also n also equals to what? N equals to m plus 1 is okay. Then n is also equals to m plus 1. Great. So let's look at, in the case, now let me look for the upper limit and the lower limit. That is where x starts from. So in the case where x is equals to, because I'm trying to replace the x here with y, right? So in the case when x is equals to 1, when x is equals to 1, it means y is equals to what? 1 minus 1, y is equals to 0. And then when x equals to n, it means y is equal to what? Y is equals to n minus 1. Because when I replace x here with n, I have n minus 1. And we know that n minus 1 is the same as m. So I can write this equals to m. It's okay. So then let me write this expression in the form of y. If that's the case, I can say that is equals to p summation of, instead of writing s equals to this, x is equals to 1, I write y equals to 0, because we know at the point where x equals to y, s is equals to 1, y is the same as 0. So I write y equals to 0. And then it sum up to what? N m, right? Because at the point where y is equals to y, at the point where y is equals to n, is the same as what? N minus 1 is the same as m. So I sum that up to m, right? Great. So when I do that, I'm going to have, and then we know that the n factorial, instead of writing the n factorial, we now know that n factorial is the same as what? Because we know that n is equals to m plus 1. So it's the same as m plus 1 factorial, right? Because that's what we know. All over y factorial into brackets. Now this here was, the expression was n minus x. This expression here was what? N minus x, right? But let's also change it to c. Let's look at this here. The n minus x is the same as, we know that n, the substitution, we know that n is equals to what? M plus 1 minus, and then we know that the x is also equals to what? Y minus, y plus 1. So when you do the subtraction, you're going to have what? M minus 1, because it comes m plus 1 minus y minus 1. So this cancels this. They have m minus y. Is okay. Great. So let me clean this. So you're going to have, so instead of n minus x, I'm going to write m minus 1. So then m minus y is okay. M minus y factorial. And then instead of writing the exponent, which is p exponent s minus 1, right? But we know that s minus 1 is the same as what? Y. So it becomes p raised to the power y. And then 1 minus p exponent n minus x. We also know that the n minus x is the same as what? M minus y. So I'm going to write my m minus y. So let me get this part. I hope it's okay, right? Good. So look at something. So from here, I know that I have p, the summation of y is equals to 0 into bracket m. But I know that m plus 1 factorial is the same as what? M plus 1 multiplied by m factorial all over y factorial m minus y factorial p raised to the power y 1 minus p m minus y. Is okay? M minus y. Great. So I can take the m plus 1, which is a constant term, also out. Then I'll have is equals to m plus 1 multiplied by p, m plus 1 multiplied by p, summation of y is equals to 0, m, right? Then we'll have m factorial, all into brackets, y factorial, m minus y factorial, p to the power y, 1 minus p, m minus y is okay, m minus y. So let's focus on this expression here, this one. So this expression here can also be written as it can be written as equals to m plus 1 multiplied by the p, summation of, when you look at this here, when you look at this expression here, this m factorial over y factorial m minus y factorial is the same as what? M combination y is okay, the same as m combination y. So that means I'm going to have y equals to 0 up to m, then have m combination y multiplied by probability of y, and then 1 minus p, m minus y is okay. So we have, now this expression here is the same as all the binomial distribution, right? And anytime that you sum the probability theory, anytime that you sum this from 0 up to m, in the case of this rate, it's always the same as what 1, it should be equal to 1. Right, so sum is equal to 1. When you sum up probability, it will give you 1. And this is summing up the probability, the binomial distribution. So this expression here is 1. So then I'll have is equals to m plus 1 multiplied by p, right? But if you remember, we said we used m plus 1 to represent what? N, right? That means I can say that this is the same as what? NP. In that case, expectation of a binomial distribution is always equal to NP. So this is a proof. This is quite easily done. So this is a proof, very easy, very, very easy. So let's look at, now we are going to look for the variance of binomial distribution. And the variance of the binomial distribution is NP into bracket 1 minus P, right? And you remember we said variance of binomial distribution, expectation of S squared minus expectation of X all squared. This is the formula, right? So we've done this one, so we know the expectation of X already. So, but we don't know this one. Now look at something, S squared. Let's try to do some manipulation. S squared, right? I can say S squared is the same as what? X into bracket, X minus 1 plus X. So when you expand this, you have your S squared by cross, S squared minus X plus X, right? So this one cancels this. So you still have your X. So I've not done anything to it. It's just simple manipulations, right? Okay, so in that case, then I can say expectation of S squared is the same as what? Expectation of X into bracket X minus 1 plus expectation of X, right? So because it follows a binomial distribution, that I can say this is the same as what? Summation of X equals to 0 up to n. Then I'll write my X in bracket X minus 1. Then I'll have n combination X p to the power X 1 minus p n minus X, right? This is X here, right? Plus expectation of X is the same as summation of X equals to 0 up to n, then X multiplied by n combination X p to the power X, then 1 minus p exponent n minus X is okay. But we know this expression here is the same as what? The expectation, right? That is what we just proved. So I'm going to use that to NP to represent that. So what it means is I'm going to have this is the same as summation of X equals to 0 up to n, then I'll have X into bracket x minus 1, n combination x, right? N combination x, p raised to the power x, 1 minus p, n minus x, plus np, right? So let's focus on only this expression. Let's focus on only this expression here. Great. So I will say that this expression is same as this part is the same as summation of x equals to 0 up to n, then x into bracket x minus 1. Then let me expand the combination. That will be n factorial all over x factorial, then n minus x factorial, p raised to the power x, 1 minus p, n minus x. Is okay? Yes, once we have this, let's try and expand this one. So I can see this expression is same as summation of s equals to, let me leave this a up to n, and I have x into bracket x minus 1, n factorial all over, but this x factorial here can be written as what? X into bracket x minus 1, and then x minus 2 factorial multiplied by n minus x factorial. Is okay. So this expression cancel this, right? And this cancel this. Is okay. Now because this expression is starting from x minus 2, that means if you start this x, if you start this from 0, x equals 0, it's going to give 0 minus 2 factorial, which is negative 2 factorial is invalid. So I start from 2, right? Great. Now you see, anytime that you write the binomial distribution, you always try to raise it to the exponent of this one, right? So I'm going to write p and then exponent x minus 2. Look at something. P it was p exponent x, but I've written out p into bracket p exponent x minus 2. Then I multiply by p squared here. So that when I add up p squared and then p exponent x minus 2, I still have my p s back. So I've not done anything to it. It's okay. Great. Then I'll just read, it becomes 1 minus p. It becomes 1 minus p n minus x. Is okay. So I can simplify it and say the same as p squared summation of x is equals to 2 up to n, and then I'll have n factorial x minus 2 factorial n minus x factorial, and then I'll have p exponent x minus 2 1 minus p exponent n minus x. Okay, so let's do a simple substitution. It's okay. So I can say that, okay, let y equals to x minus 2 is okay, and then let m is equals to n minus 2 is okay, right? If that's the case, I can say that then x is equals to what? Y plus 2, and then n is equals to what? M plus 2. I hope this is okay, right? So let's look at the limit. You know, the limit start from x equals to 2. Look at something here. The limit start from x equals to 2 up to n is okay. So because I'm trying to replace everything with y. So let's look at, in the case when x is starting from 2. So when x is equals to 2, that is the lower limit, right? All is going to be y. Y will be equals to 0. Is okay. In the case when x is equals to the upper limit, that is what? N. Right? Y will be equals to what? N minus 2. But n minus 2 is the same as what? M. Is okay. So then I can rewrite the expression and say that, okay, p is equal to p squared, right? Summation of when s equals to 2, the same as what? Y is equal to 0. Up to when when y equals x equals to n, which is the same as what? N minus 2 is the same as m. It's okay. Great. And when we had n, so when you look at this here, look at something. When you look at this expression here, we had it as what? N factorial. This one here, we had this as n factorial. It's okay. But we now know that n is the same as what? What we have, we now know that n is the same as what? M plus 2 is okay. So I'm going to write m plus 2 factorial instead of n, right? All over y factorial m minus y factorial is okay. Then I'll just bring my p combination y, and then 1 minus p, because it's p combination s, p exponent what? X, right? Yeah, p exponent x, and then 1 minus p. This is exponent what? N minus x, right? But I'm just trying to replace everything, right? So sorry, let me I know somebody's going to ask how I got m minus y, so let me clear this part. This part was right, it was n minus what? X, right? But we are trying to replace everything with y. But look at something. We know n minus x is the same as what? N minus x. N is m plus 2, right? Minus x, and we know that x is the same as what? Y plus 2 minus x is the same as y plus 2. So when I expand, I'm going to have m minus y, right? So that is why I'm replacing this expression here with m minus y factorial, okay? And then the n exponent here also becomes the same thing. It becomes m minus y. I hope it's okay. Now once we have this, so let's come to this part. Great. So we are here. Now look at this thing. This m plus 2 expression can also be written as is equals to p squared summation of y is equals to 0 up to m. So the same as m plus 2, m plus 1, m plus 1, and then m factorial all over y factorial m minus y factorial p exponent y 1 minus p m minus y is okay. So I can take the constant term, where is m plus 2, m plus 1 out. It's okay. So when I take, it's going to that take them out, I'm going to have m plus 1, sorry, m plus 2, m plus 1 p squared summation of y is equals to 0 up to m, and it's going to give me m factorial all over y factorial and m minus y factorial is okay. P raised to the power y 1 minus p m minus y is okay. So the same as equals to m plus 2, m plus 1 p squared summation of y is equals to 0 up to m, and this expression here is the same as m combination y py 1 minus p m minus y, right? So when you sum up the binomial distribution from 0 to the n, that is going to give you 1. So this whole expression is the same as what? 1. So that means I'll have m plus 2, m plus 1, p squared. But if you remember, we said let n equals what? We use n to represent m plus 2, right? If you remember, that means I can write, instead of writing m plus 2 here, I can say the same as what? N. Now, if this is m plus 1, look at something. If m plus 2 is equals to what? N, right? So let's say I subtract 1 from each side, then m plus 2 minus 1 is equals to what? N minus 1. So m plus 2 minus 1 is what? M plus 1. So let me say m plus 1 is the same as n minus 1, it becomes n minus 1 p squared, right? Then I can say expectation of s squared is equals to n into bracket n minus 1 p squared. You remember we used plus np, right? That is the first part, so you add that np part. It's okay. So this is what we have called expectation of s squared Now we're looking for the variance, right? The variance is the same as what? Expectation of x squared minus expectation of x all squared. And that is going to give you, we know the expectation of x squared as what? N into brackets n minus 1 p squared plus np is okay. And we know that the expectation of x all squared is equal to what? Minus n squared p squared. So let's expand this one. I'm going to have n squared p squared minus np squared plus np minus n squared p squared, right? So this expression here cancels this expression. Then I can say this is the same as what? Np minus np squared. So what's the common term? The common term is np. So let me factor out np. Then I'll have what? 1 minus p. So that means the variance of binomial distribution is always the same as what? Np into bracket 1 minus p. So this is quite easily done. Very simple. All right, thank you.